Here we have been asked to find that which of the following pair of organic compounds are going to be chain isomers. So the concept says that when two organic compounds are going to be chain isomers, they will have the same molecular formula, but they are going to have a different arrangement of the carbon atoms in the chain. To solve this question, we will have to analyze each of the four pairs that have been given to us. In option A, what we are able to see that the parent chain in both the pairs is consisting of 4 carbon atoms and 2 methyl groups are attached to the same atom of carbon. And when we are going to number the parent chain, as per the IUPAC system, what we are going to observe is that the methyl groups are going to be linked to the second carbon atom of the parent chain. So what we can say is that this pair does not represent chain isomers. Now moving on to option B, which has been given to us, we understand that it is a case of aromatic hydrocarbons. The parent chain in the first option in the pair is consisting of 6 carbon atoms, and when we talk about the second option in that particular pair, in option B, the parent chain is consisting only of 5 carbon atoms and a methyl group is attached to a carbon atom in the chain. So what we are able to understand is that the formula of the molecule stays the same, but the arrangement of the carbon atoms is going to change, and thus we can say that this pair of organic compounds are going to be a chain isomer. Hence option B is the appropriate answer to this question, because the molecular formula of both these compounds, compound 1 and compound 2, is the same, but what is changing is that the arrangement of the carbon atoms inside the chain. Now let's understand that why option C and why option D are not appropriate answers to this question. So now let's analyze the pair of compounds given in option C. In option C, what we understand is that the longest carbon chain is going to consist of 4 carbon atoms for both the compounds in the pair, and the methyl groups are linked to the carbon atoms of the chain. What we understand is that the molecular formula of both the options in the pair is same, and moreover the arrangement of the carbon atoms in both these compounds is the same. Hence these two compounds cannot be chain isomers. Now let us have a look at option D. In option D, what we understand is that in the first compound the longest chain is of 4 carbon atoms, and in the second option inside that pair, the longest carbon chain is made of 5 carbon atoms, and apart from the parent chain in both these compounds, there are 2 methyl groups, and hence what we understand is that the number of carbon atoms in both these compounds is different. For the first compound, it is going to be equal to 6, but for the second compound it will be equal to 7, it will be equal to 7. The formula of these two molecules is going to be different, and so thus these two compounds given in option D, they cannot be chain isomers in any case. Hence what we understand is that option B is the appropriate answer to this question, because the molecular formula of both the compounds is going to be same, I mean compounds 1 and compound 2, but the arrangement of the carbon atoms within the chain has changed. Thus option B is the appropriate answer.